This is slide number 15 and I am your presenter Asloob Mudassar. Generation of plane waves. A plane wave can be generated from a point source. A point source with amplitude equal to A located at the point x0, y0, z0 in space is represented mathematically by the point source. So point source is equal to A into delta of x minus x0, y minus y0, z minus z0. So you know that the delta function gives you an impulse when x is equal to x0, y is equal to y0, z is equal to z0. So at the location of x0, y0, z0 you get an impulse, and where A is the amplitude of the point source. So as you go away from the amplitude A is defined at the position of the point source. It will decrease by 1 over r, and the value of the amplitude at a distance r from the point source location will be A over r. So at a distance away from the point source, the amplitude will decrease by 1 over r. Here we have shown in the picture that the wavefronts emanating from a point source. The point source, you see that in the center, and the spherical waves are generated all around it. And I have shown only some parts of the spherical waves which are going towards the outer direction and indicated by the arrows. And you see that there are two small segments of a plane waves which I have shown on that last spherical wavefront. So the plane waves are small segments of a large wavefront of a large spherical wavefront may be regarded as plane wavefronts. Now you know that at a large distance from the point source, the radius of the spherical wavefronts become large enough that small portions or segments of the spherical wavefronts may become planes and may be regarded as plane wavefronts of finite sizes. The direction of propagation k is the same on such a single segment. If r is the radius, if r is the position vector of such a segment, then k dot r is equal to k r cos of 0, because there is an angle 0 between the vector k and the position vector of corresponding to that segment, and we have k r. So you see that if I talk about, this is for one segment, but if we talk another segment on the same wavefront, then of course the k will have a different direction, and then r will also have the same different direction. But you know that the product or dot product of k and r will always be equal to kr, because the angle will always be 0 on a segment. So on one segment the angle is 0 between k and r, and on another segment the angle is 0 between k and r. So this is the end of slide number 15.